Hi, boys and girls, it's Miss Bissell. We are moving right along in our topic 15, working with analyzing and graphing relationships today. We have been working on actually solving problems by looking at some numerical patterns and some relationships between some values in some data charts. Today, we're going to actually put it all together and we're going to start generating and graphing our own numerical patterns. So let's go to page 602. I'd like to look at the essential question because this is the question that tells us what we're going to be doing today. And if we can answer it at the end of the lesson, then we've had a successful lesson. If not, you guys might need to go into your practice buddy and click on the Get Help button and watch the visual learning video. I believe it's the video that's associated with the eye icon on the Get Help drop-down menu. All right, so the essential question today is, how can you generate and graph numerical patterns? So the word generate is a verb, and that basically means that you are going to create or you're going to make the numerical pattern with the information given. And of course, the verb graph means that you're going to put it on a line graph. So I need you to make sure you have one sheet of graph paper. You might need a straight edge, whether it's a piece of paper folded up or a ruler. And then you will also need your pencil. I'm going to remind you that as we work through the lesson, you need to periodically pause my video and make sure that you are filling out the example in your book. You should not come in from a remote day when I've taught a video lesson in the book and not have had the same practice problems completed as me. All right? If you're not doing that, then you're not doing what you need to do to have a successful lesson. All right, we're going to start with looking at the visual learning example right here. So we have a situation where Jill earns $5 per hour babysitting. Robin earns $15 per hour teaching ice skating lessons. The girls made a table using the rule add 5 to show Jill's earnings and the rule add 15 to show Robin's earnings. This reminds me a lot of what we were doing yesterday when we were actually generating the patterns, and each of the two people that we were working with had different rules. All right, complete the table, compare their earnings, and graph the ordered pairs of corresponding terms. Sounds like a lot of work. It's really not. The fifth grade helper reminds us that you can look for a relationship between the corresponding terms in the patterns. So let's get started. So we have Jill. She would be our X value. Remember, if we have a horizontal table of data, the X comes before the Y, so X goes on the top. All right. She earned $0 at 0 hours because she wasn't working. All right, same with Robin. If you're not working, you're not earning any money. After your first hour, you've made some money. So let's go back up to the information. Robin earns $15 per hour. Jill earns $5 per hour. All right, so that explains Jill's $5 after the first hour. It explains Robin's $15 after working 1 hour. So if Jill works 2 hours, don't we just add $5? Because her rule is add 5. All right. After 2 hours, $10. After 3 hours, $15. And after 4 hours, we just add 15 plus 5 to get $20. All right, let's talk about Robin. Robin earns $15 per hour, so obviously her rule is plus 15 every hour. All right. After 2 hours, if you add 15 and 15, you get 30. After 3 hours, you add 15 to 30 to get 45. And after 4 hours, you add 15 to 45 to get $60. All right. So we've got where the girls are as far as their earnings, their corresponding terms. At 0 hours, the terms are the same. Neither girl made any money. After 1 hour, one girl made $5 while the other made 15. After 2 hours, these are the corresponding terms, $10 for Jill, 30 for Robin. The next set of corresponding terms is Jill's $15 compared to Robin's $45, And after the fourth hour, these corresponding terms show that Jill earns $20 and Robin earns $60. All right, so we've taken care of generating the table using the rule. All right, recognizing that Jill is on the x-axis and Robin would be on the y-axis if we were graphing straight from this data chart. Now we're going to move to step B. We're going to compare the numbers in their sequences. So each sequence begins with a 0. Then each term in Robin's pattern is 3 times as great as the corresponding term in Jill's pattern. So here they are. I'm going to just work here. Somebody's already turned this horizontal data chart into a vertical one. So Jill then is X and Robin is Y. All right, let's look at the corresponding terms. They're the same here, but how do we get from 5 to 15? All right, we would either add 10 or multiply by 3. If we add 10 to 10, then for this set of corresponding terms, the rule add 10 doesn't work. So we go back to the drawing board, and what was it I said? Yes, 5 times 3 gives us 15. Is 10 times 3 30? It is. Is 15 times 3 45? It is. Is 20 times 3 60? And if you can answer yes to the rule being multiply Jill's earnings by 3 to get Robin's, then you have found the relationship between the corresponding terms. And let's go back through it. They gave it to us, but I wanted to show you how they found it. They found out that each term in Robin's pattern is 3 times as great as the corresponding term in Jill's. So doesn't that mean that Robin earns 3 times as much as Jill every hour, per hour? And doesn't it also mean we could say Jill earns 1/3 of what Robin earns for her hourly work? Now, this is new, but it's not new because we've done this before. We're going to generate ordered pairs. You guys know what that is. That's a location on a grid that has an X value and a Y value. And we're going to generate these ordered pairs from the total amount Jill and Robin have earned each hour. So look what they did. The first set of corresponding terms is 0, 0. The second set, 5, 15. The third set of corresponding terms creates the ordered pair 10, 30. The fourth pair gives us 15, 45. And the last pair of corresponding terms gives us the ordered pair 20, 60. And now that we have those, we can take the ordered pairs, we can make a line graph in quadrant 1 of the Cartesian coordinate plane. That's our positive area where the origin starts. You know what? I'm looking at Jill's earnings. She goes up to 20, so we need to at least include a scale from 0 to 20. They've taken over to 25. That works, going up in increments of 5. Robin's earnings need to go up at least to 60, so the scale is from 0 to 60. Now, the unique thing that you're going to see is that if a pattern is followed, all the ordered pairs, when you use a straight edge and connect them, all the ordered pairs are on a line. If you made a mistake somewhere, and maybe you said that Jill's earnings were 20 and Robin's were 70, then when you plotted this, the last point would not be in this straight line, and you would be able to see from that that you made a mistake. So what you need to understand is when we graph patterns on a line graph in quadrant 1 of our coordinate plane, is what we're doing in 5th grade, when we graph those points and connect them, any pattern should create a straight line between each point. If it doesn't, we've made a mistake somewhere in our work. Maybe it's the graphing, or maybe it's when we generated the pattern. All right, so what does point 0, 0 represent? I do like that question. So right here, 0, 0 means that at 0 hours, Robin and Jill have each earned $0. So let's write that down. After 0 hours, Robin and Jill have each earned $0. And we just talked about that. If you don't work, you don't get paid. If I don't come to school tomorrow, I don't get paid. 0 hours worked, 0 hours paid, okay? 0 money. All right, if you need to pause the video and look at that again, that would be great. In the meanwhile, if you're ready to move on, let's go back to page 601. I like this solve and share. You are going to need graph paper for this activity. All right, so we have a situation with a bakery, and a bakery can fit either 6 regular muffins or 6 jumbo muffins in each box. Each box will contain either regular or jumbo muffins. So what they're telling me is you can't mix them up. Complete the table to show how many of each muffin will fit in 2, 3, or 4 boxes. Then generate ordered pairs and graph them. So using the steps we just used on page 602, let's work on our data table. So X we're going to let be the regular muffins and Y the jumbo. And that's going to be important in a few minutes when we actually go and make our line graph in quadrant 1 of a coordinate plane. As a matter of fact, we did that a minute ago, so you should be looking ahead of what you think we're going to do. All right, so they started our data table for us. Regular muffins, there can be 6 in each box. Jumbo muffins, 4. So my rules, if you just want to review the rules, for the regular muffins, we can add 6 for every box. And for jumbo muffins, we can add 4. Okay? Now let's work it. So if we have regular muffins, 2 boxes, we just add another 6. So that would be 12 muffins. 3 boxes would hold 12 plus 6 is 18 regular size muffins. And 4 boxes, 4 times 6 would hold 24 of the regular size muffins. All right, let's go ahead and generate let's create the table, the pattern. Jumbo muffins, if 1 box is 4 and the rule is add 4, 2 boxes would be 8, 3 boxes, 12, 4 boxes would be 16. I am just adding 4 to my previous number of boxes. My corresponding terms are the 6 and the 4, the 12 and the 8, the 18 and the 12, and the 24 and 16. Okay, I have 1, 2, 3, 4 terms in this pattern. All right, we have completed the table to show how many of each muffin will fit in 2, 3, or 4 boxes. Now we need to generate those ordered pairs. All right, so let's look at each term. So our first term is the 6 and the 4, and the X value is the top one. So don't forget, when we make an ordered pair, the X value and then the Y value separated by a comma in parentheses. All right, the second term makes our second ordered pair, which would be 12, 8. All right, don't forget X and then Y, right? These are my X and Y values. All right, our third ordered pair comes from the third term, 18, 12. And again, 18 is the X value, 12 is the Y. We can't mix those up. And our last ordered pair that we're going to generate from the corresponding terms is 24, 16. X and Y values. All right, now the last thing we're going to do is graph them. So what are we graphing? We're graphing them, meaning the ordered pairs. So I used a piece of graph paper. I went ahead and started. This is my quadrant 1 of the Cartesian coordinate plane. You know it would keep continuing like this and that forever, right? But we only work with the positive numbers. 0 is going to go right here. So on the x-axis and the y-axis, you need to pause the video and create a number line for the x and the y. Where they meet, you're going to put a 0. All right, let's talk about what we need in terms of numbers, the scale. So on the x-axis are our regular muffins. So let's go ahead and put our label for the x-axis. These are regular muffins. And the y-axis are jumbo muffins. Remember, we turn it and we write neatly. Capitalized titles. These are our titles of our x and y axis, our labels. All right. Now, I noticed that on our regular muffins, we go up to 24, and on our jumbo muffins, our scale needs to go up to 16. So I'm thinking, I could go by increments of 2, but I'll be honest, that's going to make a very big grid. I'm going to try to cut this out and glue it in here. I don't want it to be too big. I'm thinking this works. So I'm going to go up by increments of 5, but I'm going to space it out on every other line. So watch this. I'm going to skip a line. Right here is where I'm going to have 5 regular muffins. Skip a line. Here's where 10 will be. So really, I'm going up in increments of 2.5. I'm just labeling every other vertical line in increments of 5. All right, and I said I needed to go to 25, right? Okay. Now, let's take care of the y-axis. So the y-axis goes up to 16. I'm going to do the same thing. I'm going to skip a line here. My first one is where I'm going to put my 5. Skip a line, 10. So again, I'm just using increments of 2.5. I'm going to have to estimate where I'm going to plot some of these points. But if I go from the scale of 0 to 20, I will be able to include anything up to 16. I'm good. 0 to 25, I can include anything up to 24. I'm good. My increments are consistent. I'm ready to roll. So let's look at these ordered pairs. This takes us back to what we were doing in topic 14. So 6, 4. Don't forget, when we plot ordered pairs or graph them, we can use either verb. We start at the origin and we go over to the x value, so about where 6 is. This is 5, this is 7.5, so 6 would be about right here. And we're going to go up to where the 4 would be, and 4 is going to be just a smidgen under the 5. So my first ordered pair is approximately this area. All right, my second ordered pair, 12, 8. And another way to remember direction is remember that little you run before you jump. So you're going to go over on X running and jumping on Y. If you go backwards, you're not going to have your points at the right place. All right, so 12, 8. So we run along the axis to 12. 12.5 is right here, so we're right before it. And we're going up to 8. And 8 would be about right here. It's going to be between, 7.5 and 10. Closer to 7.5. All right, my next ordered pair, 18, 12. Notice I go back to the origin each time. I'm going over to where 18 would be, just a little bit past this 17.5, and I'm going up to 12. So 12 would be almost to the line, so something like this. Okay, and my last ordered pair, I'm going to go over to 24 on the X value, so about right here, and up to 16 on the Y, so probably just about there. So I have my 4 ordered pairs that were generated from my 4 corresponding terms on the line graph. Now, this is going to be, see how good I really graphed them because I had to estimate some, so they should be pretty close. All right, I have one that I might need to do something with, and it's not that the data's wrong, it's just the graphing. So this one right here should have been down just a smidgen to be about right here. Okay, so my ordered pairs are in a straight line, and they should be because we have a pattern where we're adding 6 muffins every time on the x-axis and 4 every time on the y. Okay, so there it is. We just generated our ordered pairs, and then we graphed them. Now, I'm going to take this, I'm going to cut it, and I'm going to glue it in my book. So, guys, you should be able to do that. If you don't have any glue at home, you know what? You can always use some tape, clear tape. So right here is my work. Nice and neat. Didn't have to try to draw vertical and horizontal lines. All right, some of you, I tried to give a warning that you were going to need to have these materials. So right here, we're just going to tape it in. Okay. All right. Now, I would like to look at another problem. So let's flip in our book. And if you need to pause me and finish this up, do that by all means. Those of you that are ready, we're going to page 603. And I really want to work on Megan and Scott and their fishing. All right, so here we go. They're telling us to use the rule add 4 to help us. So Megan and Scott are going to go fishing while at camp. Megan catches 3 fish in the first hour. It's already been plotted for or written for us. And 4 fish each hour after that. So that's important. So it looks like her rule is add 4 fish every hour. Scott catches 5 fish in the first hour. That's already put into the data chart. And 4 fish each hour after that. Oh, guys, that's just like what we did on Monday. Our corresponding terms are actually going up the same amount. Complete the table to show the total number of fish each has caught after each hour. So if my rule is add 4, then Megan after 2 hours will have 7 fish. After 3 hours, 11. And after 4 hours, she should have 15 fish. Scott starts with 5. After 1 hour, he should have 9. After 2 hours, he should have 13. And after 4 hours, he should have 17. All right, so we've completed the table to show the number of fish. All right, so that is done. Check. Number 6, what ordered pair represents the total number of fish they each caught after 4 hours? 4 hours is right here. So here is our ordered pair. Don't forget, the left would be your X value, the right would be your Y. All right, so if we made an ordered pair, wouldn't that be 15, 17? Written just like this. All right, now we're going to graph the ordered pairs of the total number of fish that kids have caught each hour. So we're going to need that graph paper again. All right, I'm going to need an X and Y value. So here we go. This time you get to see me make it. So we have our X and Y axis because we're going to need to put our X and Y values on here. All right, our origin starts here. Now, what I know, I'm looking at my information. So I know that we need to do Megan and Scott. So Megan's going to, her fish in E, yes. Megan is going to be on the X axis because she's on the left side of the table. And Scott is going to be our Y value information. All right, let's work with Megan. We're going up to 15. All right, so I'm thinking let's do increments of 2. Let's see, 2, 4, 6, 8. No, let's not do that. Let's do increments of 3. So this would be 3, 6. You know what? I'll make it even easier. Let's do increments of 4 every other line. So let's do 4, 8, 12, 16. Now, wait a minute. We have to go to 16. We're good. All right, for Megan. And that means that every vertical line is really an increment of 2. That'll be easy to plot. So we have enough on our scale if we go to 16 to include Megan's 15 fish. Scott, we've got to get up to at least 17. So why don't we do the same thing? Let's do increments on every other line. 4, 8, 12, 16, and then let's just go up one more. That's why we do pencil. And let's do 18. All right, so just recreate that. Okay, so I've got Megan's increments. Really, we're going up by 2 on every vertical and every horizontal line. I just labeled every other to make it not so jammed with numbers and hard to read. Now, we need to graph the ordered pairs. Well, wait a minute. We need to write the ordered pairs. So let's write them right here. Our first term is going to be 3, 5. So the X value is 3. The Y is 5. So Megan caught 3 when Scott caught 5. The next term, 7, 9. We'll graph the ordered pairs 7, 9. Our next corresponding terms would be 11, 13, and the last will be 15, 17. All right, so let's work on this. 3, 5 is our first ordered pair. So we're going to go over to the 3. So here's 2, so that's halfway. And we're going up to the 5. So that would take us, let's see, that's 6. So we're going about right here in the very middle of that square. 7, 9. So this would be 4. Let's see. Wait a minute. Let me go back. 3. This is 2. Yep, that would be 3. This would be 4. Yep, I'm good. All right, 7, 9. This right here would be 6. So 7 would be halfway. 9, we're going to go up. This would be 10. This would be 8. So 9 is going to be in the middle of this one. 11, 13. Here's 10. So we're going halfway over to 11. Here's 12. We're going halfway up to 13. And then here we have 15. Let's see, 14. So we're going halfway. 17 is going to be right here. And you know, we can always do this too. We can always label the points on the graph. 3, 5, 7, 9. You've seen some graphs constructed like this. 11, 13, 15, 17. Now, if we graphed correctly, we should have a line that goes through these. We started at 3, 5, and for all intents purposes, I've done a pretty good job here. I have a straight line right there. So my pattern looks good. All right. Now, there is a question. What relationship do you notice between the total number of fish each has caught after each hour? So how do we get from 3 to 5, 7 to 9, 11 to 13, 15 to 17? Guys, when we go from a smaller to a larger number, 2 operations get us there. It's either going to be addition or multiplication. But whatever we think it is, it has to work for each of these 4 terms. So, you know what? 3 times nothing gives me 5. But 3 plus 2 gives me 5. All right. Now, the question is, will 7 plus 2 equal 9? And it does. Keep going. Will 11 plus 2 give us 13? It does. Keep going. Will 15 plus 2 give us 17? It does. So the relationship that I noticed is that Scott will always catch 2 more fish than Megan. If Megan catches 100 fish, Scott's going to catch 100 too. So let's write that out. Scott always catches 2 more fish than Megan. Now, we could always say that Megan always catches 2 fish less than Scott. We could go that route too. Either way, that's our relationship. All right. So this is cool. Here's a nice question. The pattern continues like this until Scott's total is 29. So what ordered pair represents the total number of fish they each have caught when Scott's total is 29? So wait a minute. Scott always catches 2 more fish than Megan. So when Scott catches 29, I had to figure out Megan catches how many? That's right. It would be 27. She catches 2 less. So she's the X value. So wouldn't the ordered pair be 27 for Megan when Scott, the Y value, catches 29? All right. I'm going to cut this out and just staple it in my book. You guys can figure out how you want to handle that graph since there's not anywhere to really glue it. I'm just going to leave it here with 2 problems worked. Generating and graphing ordered pairs definitely builds on what we've been doing the last 2 days, and the graphing part actually covers what we did last week. So the question was, how can you generate and graph numerical patterns? So I hope that you're able to answer it. You use a table to use some kind of a rule, whatever it is, an hourly rate in this case, to generate your table. Then you take your table, you look at your corresponding terms, you write your ordered pairs from them, And from that point, you graph them into quadrant 1, and you're creating a line graph. All right, if it's right, your line makes a straight line with all points in order. All right, boys and girls, I hope you have a wonderful day. You are going to work on your practice buddy for lesson 15.3. Make sure that you're working out your calculations on paper. Just head your paper, PB for practice buddy, 15-1 for lesson 15.1. Put today's date on it and put it in behind your math work when you're done. All right, have a wonderful day. I'll talk to you soon.